find D. You find D. You have to find D. Okay. D. Because pressure variation show you that pressure different between 2 points. Okay. And if you know the distance between 2 points, so if you know pressure between 2 points, you can find the distance. Because, for example, you want to find D, you can find D if you know pressure B and pressure C. Because you will have between B and C, you will have PB minus PC equal to rho D. Yeah. I'm sorry, rho ZS. Sorry, here is I forgot Z here, and I forgot S here. Rho ZS on rho ZS. So sorry. Rho DZ. Okay. Rho ZD. Okay. The distance between point B and point C, PB minus PC, will be equal to rho ZD. Okay. The equation. So to find D, you have to know PB and PC. And to find PB,
isn't PB pressure?
Yeah, P pressure.
So how would knowing the pressure be on the distance? Oh, okay.
Because pressure depends on the distance. Yeah. Pressure different between 2 points based on the distance between 2 points. Okay. So PB, how to find PB? How to find PB? Formula, but based on which point? You have to find PB, and you know the distance between B and A, so you can find PB if you know PI.
What is A? Is A like ground?
A is a water surface. Water surface. Water surface, yeah.
So A is water.
Yeah,
like
water surface.
All of that thing is underwater.
B and C is under the water. A is water surface.
Like there's a pocket of air.
Yeah. And in here is air. We have air.
Okay.
Or atmospheric pressure. It's 101.3 kilopascal. It's absolute pressure of atmosphere. Or if you use gauge pressure, it's 0 gauge, 0 kilopascal. It depends on you use absolute or gauge pressure. Okay, because gauge pressure is a pressure different between absolute pressure and ambient pressure. So for ambient, the difference between ambient and ambient is 0. So gauge pressure of ambient is 0. Okay. Yeah. I show you here to more understand about pre-coil pressure. You can have a look in the slide in lecture 1. Okay, have a look at it again. We have this one. Pressure, we have absolute pressure, gauge pressure, and barometric pressure or ambient pressure. Okay. Gauge pressure is from this pressure sensor here. So pressure different between absolute pressure of air inside this tank and ambient pressure. Okay. So this one show you gauge pressure. Gauge pressure will be equal to absolute inside the tank minus ambient outside. Okay. So for the ambient, if inside this tank is ambient and outside is ambient, we will have gauge pressure of ambient is 0. Okay. So gauge pressure of ambient is 0. Absolute pressure of ambient is 101.3 kPa at sea level. Okay. Oh, sorry. Okay. So you can find PB if you know PI. And PI, pressure at the water surface will be equal to atmospheric pressure. atmospheric pressure. Okay, and atmospheric pressure, you can use 101.3 kPa absolute or 0 Gauge. It's up to you. The result is same. Okay. PC. How to find PC? PC. How to find PC? Between C and D is air. Air, so pressure is the air. The pressure change in the air is very small. Which means pressure difference between C and D is very small. C is the water surface. D is mercury surface. But all of them equal to, you will have, this one is inside. For example, PO is pressure inside this container. So PC will be equal to PO, and PO equal to PD. Okay, pressure on the surface equal to atmospheric pressure, and atmospheric pressure inside this container. Okay, so PC will be equal to PO. PO is pressure inside the container, and pressure inside the container equal to PD. Okay, what mercury surface. So PC you can find if you know PD. Okay, PD. And PD, because you know the distance between D and E, so you can find PD if you know PE. Okay, because distance between D and E is 0.7 meter. And PE, mercury surface, will be equal to atmospheric pressure. Is 101.3 kPa absolute or 0 kPa gauge pressure. Okay, this one is process how to find the distance D. Okay, so now we will start with the 5 PA. So we have to find PA. When you have PA, we have 5 PB. Okay, 5 PE, have PE, 5 PD, have PD, 5 PC, and after that we will have D. Okay. So in this case, you can use atmospheric pressure is 0 or 101.3. It's up to you. But I will use 0 gauge pressure, easy for calculation. Okay. So we have atmospheric pressure already, and PA will be equal to atmospheric pressure 0 gauge, 0 kPa. Okay, we said that we use gauge pressure already. PA if on the water surface equal to atmospheric pressure. When we have PA, 5 PB. Okay, PB, because B below A, so PB will be higher than PA. PB minus PA equal to rho Z, and the distance between B and A is L, rho Z L. Okay. Rho is a density. This one is rho of water, because between A and B we have water. Okay, so rho of water here is 1,000 kilogram meter cube. Z is 9.61. L here is 12 meter. PA 0. So from this one you have PB. Okay, so PA you have atmospheric pressure you have, PA you have, PB you have. Okay, now the second line, PE, mercury surface, will be equal to atmospheric pressure. PE equal to atmospheric pressure or 0 kPa gauge pressure. When you use gauge pressure, other pressure is gauge pressure, not absolute. Okay. PE 0 gauge. This one you have from PE, you find PD. This, you have the distance between D and E is 0.7 meter. And you have D below E. Okay, so you will have PD minus PE equal to rho Z H, rho ZH. But remember that between D and E, we have mercury here, this one. So the density here, the density is this equation, is density of mercury, not water. Okay, because between D and E is mercury. So the density of mercury we have from the table. Yeah, mercury density 13,600 kilogram meter cube. So be careful if you use density of water in this case, it's wrong. Okay, this one is between D and E, we have mercury. Yeah. This one is 13600 kilogram meter cube. This is 9.81, and S here is let me see, 0.7. Okay, PE is 0, so you can find PD. Okay, and PD equal to PC because equal to PO is a pressure inside the container. Okay, so you have PC equal to PD. PC you have, PD you have, PC you have. Okay, now based on this equation to find the distance between B and C. Okay, the distance between B and C, you will have PB minus PC equal to rho Z D, and between B and C is water, and B below C. Okay, B below C, so PB minus PC equal to rho of water ZD, and you will have D equal to PB minus PC over rho of water Z. With PB you got it here. Okay, PC here, rho of water is 1000. This 9.81. Okay, so from here you can find D, the distance.